If you're holding a chunk of coal in your hand, the chunk of coal that fits in about the size of your hand has so much energy in it. It has enough energy to propel your body, about 5.5 miles. If you go outside this studio right now and you find a rock that's the same size, and you ask how much energy is in that nuclear energy, the answer is about 100 times more energy than the chunk of coal.
Are you serious? What are some of the red pills the nuclear red pills that nobody's talking about?
Yeah, nuclear is really counterintuitive. People do not understand the magnitude of nuclear. So before I talk about nuclear, let's talk about coal for a second. So coal is really cool. I like coal a lot. If you're holding a chunk of coal in your hand, you're holding a pretty extraordinary thing, right? You're holding a chunk of energy, and that's super exciting. So, if you're digging and you find a chunk of coal, what have you found? Well, holding it in your hand, the chunk of coal that fits in about the size of your hand has so much energy in it. It has enough energy to propel your body, about 5.5 miles into the sky, right?
Wow.
If you expended all that energy on pushing you up off the surface of the planet, you would go about 5.5 miles into the sky. If you put that into a car, right, which is a big, heavy thing, it can take all your family and your groceries and everything, you can go about 10 miles down the road with, that chunk of coal. So it's an extraordinary, extraordinary thing. And it served us very well as humanity to be able to do that. Now, one very, very counterintuitive fact about nuclear is that nuclear fuel is spread all throughout the Earth, right? There's a couple of caches and deposits of uranium and thorium that are more concentrated, but nuclear in general is just like spread throughout the Earth. So about 10 parts per million of every just rock outside has 10 parts per million is nuclear material. There's trace nuclear material in basically every rock that you pick up outside. Here's a crazy fact for you. So we talked about this chunk of coal that fits in your hand and how much energy it has in it. If you go outside this studio right now and you find a rock that's the same size, and you ask how much energy is in that nuclear energy, the answer is about 100 times more energy than the chunk of coal.
Are you serious?
Every single rock that you pick up outside of the studio is as if you're holding a 100x chunk of coal in terms of energy. If you take those trace amounts of uranium and thorium and you were to fully fission those in a fast reactor, you would get 100 times more energy, which is, to take our original example, enough to propel you about 30 kilometers, your body off of the Earth. So about a third of the way to space. Every single rock that you find out in the garden on the side of the road.
Wow.
So nuclear is the future, right? You can look at that and say, okay, when we discovered nuclear energy, we essentially discovered that the entire planet is as valuable as a coal mine, right? Which is very valuable and very energetic. So I think people underestimate radically how much nuclear fuel there is. It's under our feet at all times. We could be using it. We should be using it.
You had mentioned being able to convert, I don't know the terminology. You mentioned being able to convert nuclear into burning clean gas or
Yes.
something like that. Can you elaborate on that?
Yes. So this is really, really exciting. We talked a little bit before, I think before we started the cameras here, about what does the future of energy look like? Do we use all nuclear, or do we continue using oil and gas? A very contrarian thing that I believe is that I think that humanity continues to use hydrocarbons, right? So we're talking about diesel, jet fuel, gasoline, for a long time. And in fact, I think that hydrocarbons are sort of the perfect fuel. It's hard to imagine a better fuel than a hydrocarbon. It's very dense. It could be a liquid. It's non-toxic. It has elements you already find in the atmosphere. It's one half of an oxidation reaction, which means the oxygen's already there. So you only have to carry half of it, right? Normally with chemical energy, you need to carry 2 buckets around, right? And then you mix the buckets and you get heat. Well, hydrocarbons, you only carry 1 bucket because the other half of the bucket's in the air. It's oxygen. So it's sort of the perfect fuel that you could imagine. But where does it come from, right? So right now it comes from underground, which is fine. It's served humanity very, very well. We've propelled ourselves to the civilization that we are today, essentially through drilling oil and burning it. And that's awesome. But I think we can do even better. The way that we do even better is that we are eventually going to get hydrocarbons from the air. What do I mean by that? Well, the air already has all of the ingredients for a hydrocarbon. It has carbon and hydrogen, right? So the carbon is in CO2, which is everywhere in the atmosphere. The hydrogen is from water, which is also everywhere in the atmosphere. And all you need to do is energize CO2 and water. So it's sort of, think about this like reversing combustion, right? So when you have combustion, you start with a hydrocarbon and you mix it with oxygen and you get energy out of that and you get CO2 and water, right? So that's combustion in a normal engine. We kind of do the opposite. We start with those combustion ingredients, the CO2 and the water. We put energy back into them and we get a hydrocarbon. So I believe that that process will be driven by nuclear. And what that means is we're essentially using hydrocarbons as a distribution mechanism for very cheap nuclear power. So if you have a bunch of nuclear reactors all on a campus, again, we call this a gigasite, you're producing huge amounts of power, and we can certainly push electrons in a wire and produce electricity, but we can distribute all of that valuable energy in another way, which is to build hydrocarbons and then ship the hydrocarbon, right? So this is like us producing energy, forming it into a hydrocarbon, and then shipping that energy in the form of a hydrocarbon. And I do believe that as nuclear becomes cheaper and cheaper, that the price of that hydrocarbon is going to become significantly cheaper than oil. It'll become cheaper than drilling oil and refining it and distributing it.
Interesting. I am kind of surprised to hear you say that we still have a place for fossil fuels.
Absolutely.
We see, obviously Tesla,
Yep.
they're doing I saw, I think it was last week, they started the robo taxis in
Yep.
Austin. A lot of the cars are going to batteries. Talked to Dino Mavroukas, the
Yep.
CEO of Saronic, and he's talking about how they're powering their small boats and batteries. Some
Yep.
of the bigger ones are doing diesel, but
Yep.
why wouldn't you want to put a small modular nuclear reactor in something like a naval vessel,
Yeah.
or a car,
Yeah.
and get rid of all this shit?
Yeah. So I think the short answer is like EVs are going to continue to be a massive thing. I have a Tesla Model 3. I love it. It's amazing. I never have to fill it up. I also have a gas car as well, and that's useful for other use cases. I think the answer is we're going to do a lot more of both. We'll have a lot more battery powered things, and we'll have a lot more hydrocarbons. And the reason is there's something very irreplaceable about a hydrocarbon. And those things are energy density, right? So energy density meaning how much energy do you get per weight and per volume. So if you have a container, right, you have like a box that you're putting either a battery in or you're putting a fuel tank in. Hydrocarbons are about 40 times better than batteries, right? So in the same amount of space, you can carry the same amount of weight, 40 times the energy. So that's pretty irreplaceable for things like aircraft, for example, right? An F-35 Lightning is never going to be powered by lithium ion. It's just not, right? You have to get the power density of a hydrocarbon to run that thing. There's a class of ships, right, which will always need something with the energy density of a hydrocarbon. You just can't fit all those batteries, and they're going to be too heavy to run, a long-range ship. Short-range ships, for sure. Smaller ships, for sure. And then, absolutely, there will be some nuclear vessels as well. But there's just this really broad set of use cases where you need energy density, and hydrocarbons just have such incredible, irreplaceable energy density. The other thing is they're
nuclear wouldn't fill that.
So for cars, for example, I don't think so. I don't think that we'll have nuclear cars. Or let me say it another way. I think we will have nuclear cars, but it will be nuclear generated diesel that then goes into a car.
Gotcha.
Or nuclear generated electricity that powers a car. Nuclear reactors don't like being small. There's sort of a minimum size that you want to build a nuclear reactor, and trying to get it smaller than that is a very, very difficult engineering challenge.
No matter where you're watching Shawn Ryan Show from, if you get anything out of this, please like, comment, subscribe, and most importantly, share this everywhere you possibly can. And if you're feeling extra generous, please leave us a review on Apple and Spotify podcasts.